Good morning.
Good morning, sir.
Fine. So welcome back. So sorry, yesterday I could not take the class because of some internal meeting regarding the COVID and other academic requirements. So anyhow, hope you have received the notes on Azure. Hope you have gone through that. So quickly, if you have any doubts on that or any clarification required, we can take and we can go to the next concept, that is the last one, which is the cloud computing applications. I think I've just shared the notes on that as well. Hope you have both with you. So once you are done, probably we can go through that. Maybe a couple of minutes. Let us wait for the others to join. So once that's done, we can go forward. Meanwhile, I would like to know how you people are placed. Where are you? How are you? What is your health status? I heard a couple of you having cough, cold, fever. So how things at your end, especially those who are in hostel in the campus. So Raman, what happened to your testing? Is done?
Yes, sir.
Okay, fine. So take care in the hostel. Don't move around.
Yes, sir. I'm not going
Equally,
anywhere.
but all are asymptomatic, but still, why to take risk or chance? So be to yourself and avoid going to the public or places where crowd is there.
Yes, sir.
Yes. How many are there in hostel from MCA?
From MCA, sir, I am only one.
You are the only one. Okay.
Yes, sir.
How about Anaka? How is the PG?
So I came to my hometown, sir.
Okay. So how about Divya?
Sir, I came to my home, sir.
No, yesterday I saw you have some fever and all. What happened?
For me, sir?
Hmm.
No, sir.
In the Google form, that's what mentioned against your name.
No.
I am not feeling well, fever, something.
No, sir, I didn't.
Okay, then who has filled
Yes.
that?
I don't know, sir, but I felt no only, sir.
Okay, fine.
Yes.
How Rashmi?
Yes, sir. Good morning.
Those who are in PG?
So I came to my home, sir.
Okay, fine. Fine. So hope you all have the notes both from Azure as well as cloud applications. Is the screen visible?
Yes, sir.
Yeah. Could you go through this? This is in continuation to the two examples of real-time what you have taken on AWS and GAE. In continuation, we have Azure from Microsoft, which is a PaaS platform that we are going to talk about. So in fact, we have taken one IaaS, that is AWS, and one PaaS, that is in the form of GAE, and another PaaS we are looking from a Azure perspective. Since Microsoft is having its own well-built data centers, as we already seen in one of the videos, it is providing the basic requirement of a infrastructure on its own data centers. On top of it, it is majorly connecting with the cloud computing world through PaaS. Azure is mainly or majorly known widely in the globe for its PaaS offerings platform, on top of which we can develop our applications. That's what the main advantage or maybe main contribution from PaaS. And the infrastructure, you need not worry as a developer. Infrastructure will be taken care by the system, that is Microsoft itself. So unlike any other pure PaaS, where in pure PaaS we will not be having infrastructure, but in this PaaS platform we have infrastructure. Even the same thing with the GAE. Google also provides its own IaaS. The developers need not worry about the how to maintain the infrastructure from their end. They have to just provide the or ensure the SDK is used to develop their own applications and start floating them or deploying them into the cloud of GAE. In the same way, we have Azure as well, where Microsoft takes care of the entire IaaS requirements of the platforms, on top of which our applications can be built using the variety of packages or variety of development kits that is provided through PaaS. So PaaS is a major contribution from Microsoft Azure. So the diagram, if you look at, just a brief architecture of a Microsoft. It is similar to any other cloud platform where we have a IaaS backup. On top of it, we have a PaaS. On top of it, we have a SaaS. That is the common structure across the cloud computing arena what we have. But here, since we are talking mainly about PaaS, our concentration will be on PaaS related concepts. So as we have seen in the GAE, where we had a compute service, we had even AWS, we have seen compute service, storage service, networking service, database service, even the security related aspects. All those things were there in the AWS because that is majorly the bottom, that is a IaaS platform. Here, IaaS is not majorly given, but PaaS perspective, again, we require a compute because computation is one of the important requirement for any type of cloud offering when you go from IaaS, PaaS to SaaS. And storage, of course, we need to work on the storage. But here the concept is like we had S3 in the AWS, we have a SQL Azure, which is going to help us from that particular perspective. And we have a networking, all those CDNs which were there in the AWS, they're all available in the PaaS of Azure from its own perspective. And Fabric, App Fabric is something which is important from Azure perspective, Azure point of view. On top of it, we have that entire management portal, which is going to provide us the complete set of what you call development tools or SDKs that is required to develop. And it also provides a local environment so that, because as we know, data centers are spread across and we cannot every time connect with the main data centers, thereby the replication, which we talked about normally, the three number of replication that is going to be valid or available here as well. And we have that local development team for our own, because PaaS is mainly for developing our tools or our applications rather. So local development area is also provided based on the very close proximity of the, or maybe the close by data center that is available for the given particular development or a particular user per se. So that is how the architecture is all about. The bottom one is IaaS, which we are not going in detail because we know Azure as a PaaS platform, thereby we will not get into the IaaS prospects or aspects of the Azure. But our concentration is mainly on how a user can develop or a developer can develop his or her own applications is what our concern. For that purpose, we require a compute, storage, networking, and even the how the other SDKs are going to be provided here. And the difference what you can see between GAE and Azure from PaaS platform perspective is GAE majorly uses its platform to provide majority of services or applications which are free of cost to the mass or public. That's how the GAE is working, or that's how the concept of GAE PAS, even though it uses GAE for its own other purposes, which are of commercial nature, but it has major applications being deployed on its platform for the public. But when you come to the Microsoft Azure, here the concept here is majorly for a corporate sector, which is based on a license. As we know, we have a .NET, we have other proprietary softwares or tools from even Visual Studio, tools from Microsoft for the last 20 years. And these tools have been given to the market on a basis of a commercial products, right? So Microsoft is tapping on those expertise of its own softwares and trying to give the PaaS platform. That is the reason why Microsoft entered into PaaS platform, because it knows that it has variety of software packages which are already being given to the market on sale basis, or maybe on a price of some particular price on a commercial format. So that they have tapped, and they thought, why don't we have our own platform where through that platform they can reach the mass and they can reduce the cost from the subscriber perspective. And that is the reason why majority of PaaS related applications, SDKs, or maybe the tools are part of this particular Azure. Or that is the reason why Microsoft entered into the cloud through PaaS platform. So once you get into the Azure through, as usual, with the login or whatever the credentials we have, we'll be enabled, or we will be given a flexibility to choose the type of development kits or tools we need, majorly owned or licensed from Microsoft. So that's what the understanding or idea with the Azure. Since we are all using majority of Microsoft tools in the form of maybe Visual.NET, or maybe your .NET platforms, or ASP.NET or .NET framework per se, so people will be going to the Windows Azure from that perspective, because some of the areas we don't have competitors in that, thereby people are going with the Windows Azure. So that is the precise idea behind how Windows Azure came into market and what it offers. So majorly it is a completely a commercial format as far as the PaaS of Azure compared to GAE PaaS, where GAE majorly it is for the public, it gives free services, whereas Windows is contrast, completely it is on cost basis. I don't think there is any even a single free service available from Windows on Azure platform for the public. We have to pay something and get, including Office 365. Unless you have a subscription for your Windows, it will not be providing access to that Office 365. So this is how it happens in the Windows Azure. But nevertheless, the underlying concept is same, whether it is GAE or a Aneka or it is Azure. The underlying concept is, on top of the IaaS, we are going to build this type of technologies where the user can make use of this irrespective of the location wherever they are, at less cost. That is the underlying feature, and that has been followed here as well. So coming to the other aspects, I think you can go through that, but majorly I would like to touch upon 3-4 points here. When it comes to the compute services, we have different role plays from each of them, because it has to provide a commercial platform, and user should be having a flexibility to choose the type of computation. That is the reason why we have 3 different roles at the computation level, and we have one main concept called blob at the storage service. These are the 4 points what we should be knowing. And last, we have a SQL Azure, which is something different from what we have seen from S3s and others. So SQL Azure is completely meant for this particular Azure platform. Thereby, we can touch upon that as well. So coming to these different roles at computation level, we have a web role, we have a worker role, and we have a virtual machine role. They are not different from any other activity, but they have been categorized just to ensure that the users or customers or the developers will have an environment which is customized to their requirement. When someone wants to have a scalability related thing, probably you can get into the web role. We can ask for a web related activity, or computation can be from a web role perspective, and we can look at that particular scalability of applications. When it comes to and all these things are based, as I said, they're based on a .NET, because .NET is the main component, or maybe the main software that is possessed by Microsoft at this point of time. Then coming to the worker roles, they are mainly for having any generic idea. I mean, any normal activity that you want to do, any simple activity that you want to do, probably can take for a worker role. But when it comes to the virtual machine, since cloud computing is majorly on a virtualization concept, so virtual machine you want to engage on your own, and you want to what you call manage the virtual machine from your end, probably we can go for a virtual machine role. So when it comes to the web role, it is mainly for scalability. When you want to handle the scalability issues, then probably you can go for a web role. When it comes to hosting very simple applications or normal or generic applications, it is a worker role. When it comes to the VM, probably you will be taking a full control of the entire system or the entire fabric, I can say, from Azure perspective. So if that is the case, probably you can. But all these things are going to be completely based on the .NET technology. That's what the main activity or main component behind or from the Azure perspective. So these are the things. And you know that Windows, we had a Hyper-V virtualization platform or tool which we have taken, and this virtual machine role is completely in line with those particular Hyper-V that we have seen already in the virtualization discussion. Then coming to the storage, which is important for us, there we talk about a blobs. Like we had a S3 buckets or maybe various other concepts of a storage from each provider perspective. Here they are going to be called as a blobs. Each blob is nothing but a very large object of a binary nature, and they can grow as small as 4 MB to around 200 GB in a single block. That is very huge number. We have seen already some 64 MB in each block in the GAE, but today we are talking about a storage of a minimum of a 4 MB of each block, growing up to 200 GB as far as the blobs of a Azure are concerned. So otherwise, they typically constitute how the storage is going to take place. So nothing great beyond that, but this is specific to the Azure perspective. Thereby, the storages we have to deal from a Azure, because each vendor have their own processing or their own way of dealing with the objects or the processing. So Azure looks at these things, these values or these storage components as a blobs. And of course, we have a variety. You might have seen while discussing in OS also, we talked about paging and page tables and all. From that perspective, minimum two categories they follow here. One is a block related blobs, and other one is a page related blobs. So the 200 GB what we talked is majorly for a block related, whereas if it goes to pages obviously of a greater size. Even in the memory hierarchy, if you see, we talk from a bit, nibble, byte, we go to the blocks, sectors, all those categories we have. At the end, we have a pages constitute the highest what is called a portion of a or a partition of a memory. If that is the case, page should be always should be capable of holding much data. Thereby, the blocks are going to up to 200 GB. Where the blocks earlier was 64 MB or close to 1 GB or 10 GB maximum in the case of a GAE, but here it goes up to 200 GB. Whereas in the case of a page related blobs, you can easily have one complete hard disk. So one page is almost equal to a complete hard disk type of setup we have in the Azure. So that's the greatness of a storage what we have in. Since we are paying commercial related activities, probably that is possible. Whereas in GAE, it is majorly free software or free solution. Thereby, people are not able to feel that particular storage because they have to serve billions of people at free of cost. But here 1 TB is possible when the page blobs are considered in the micro. Again, you have to be clear in this what type of storage you require. If you want less storage, you can settle with the blocks, or if you want a greater storage, you can go with the page, because at the end we are going to pay for each of the services we are going to get from any cloud perspective, and more so with the Microsoft Azure, which is a completely a commercial platform or a commercial pricing. So this is how the concepts are available with respect to the Azure. And App Fabric, I think Fabric is the one name people use in the software industry, where these things are going to be floated to the public, or maybe to the users rather. And Azure Fabric majorly is based on a .NET. And if you recall, we had a Java and Python from a GAE perspective, because again, as I say, it is a free. They could not have much. Probably when you go to the commercial, we might have Python, Java, and even beyond that PHP. But here in the case of Azure, we have .NET, we have Java, we have Python, we have PHP, we have Ruby on Rails, all those things, because majorly Microsoft Azure is a PaaS platform. It supports all possible SDKs or all possible developments environments, so that we can start building our applications. So that is the main agenda of a Microsoft Azure. So in GAE, you may not get maximum, because GAE, even though it is a PaaS platform, that is for internal purpose. Outside, we look at GAE from a SAS platform. All the applications of GAE we use from a SAS perspective. Whereas in the case of Microsoft Azure, there is no SAS majorly here. Completely, it is a PaaS. Thereby, flexibility is there with respect to the multiple development kits or tools with respect to the Azure services of a cloud. And almost all the services or development kits required for PaaS are possible, are being available, or made available rather, in a Microsoft Azure cloud service. And the last concept of this Azure, probably we can touch upon, like in lines with S3 or buckets we had in the AWS, we have a SQL Azure, which is, since we talk about computation, storage, networking, all are taken care by the platform which is given through the Microsoft Azure. So obviously should have a very robust way of storage. Already we have seen how the storage capability is there, 200 GB in the case of block blobs. If it is page blobs, it is going to be 1 terabyte. So that is already, we have seen the type of service or type of strength we have from the storage perspective. Internally, to store them, we are going to use the same SQL, but it is going to be customized for the Azure perspective. It is completely RDBMS that we have already. So that will be part of this. And since it is not only a standalone requirement, since it need to be scaled or scalable, scale up, scale down, and it has to be massively connecting, retrieval, storage, all these are required. Probably the APIs related to the web, like REST or SOAP, they are going to be part of this particular culture or particular requirement, because your SQL Azure cannot be slow. It should be as fast as anything, because many times bottlenecks might be possible at this level, is the storage level, or a computation level, or a networking level. If one is good, for example, let us say computation is fantastic, but the storage is not that great, probably you will not be able to visualize the performance. On the other hand, if computation is good, networking is not that great, probably again you will not be able to have a seamless floating or seamless connectivity. Then probably we also feel that services are not that great. So to ensure that any cloud or any network related software or network related platform is providing service, we need to have both computation, storage, networking at the minimum level should be functioning with a highest availability or highest reliability. Then only probably we'll be able to ensure that our services are given. So from that perspective, SQL Azure is rather built or maybe customized from the Microsoft perspective to ensure that all its PaaS users will have a very compatible or comfortable storage from a database point of view. That is a major idea behind the SQL Azure. So it all depends on, since it is a customized project, we have it is a commercial product, we'll have a customizable SQL Azure. That is the reason why we have two editions of it at present. One is a web related edition, other one is a business edition, because that is what the major idea behind this. All enterprises, if you want, probably you need to have. So that is the reason why if you look at web edition, the maximum size is limited to 5 GB, whereas in the case of a enterprise or business, it is tenfold greater. So it is up to 50 GB, depending upon the type of enterprises or applications we have. So SQL Azure is also capable of having the tables or any related idea or any related requirement to be growing up to 50 GB if we have a enterprise application or a business application. So this is precisely what a Microsoft Azure PaaS platform. So what we have to understand here is what are the various technologies that are given from Microsoft Azure. They are basically .NET related, or maybe your Visual Studio related type of technologies, in addition to the existing Java, Python, PHP, Ruby on Rails, and stuff like that. Second important is the various roles we have from the computation. One is a worker role, web role, and VM role. Depending upon the type of control we need to have on our own what you call software development tools, we can go for that. Accordingly, the pricing will be there based on the type of control we have. And second, SQL Azure, which is a majorly customized for the Azure, PAS platform of Azure. So the customers can have their own tables and other stuff through the Azure. And coming to the application, majorly, as we know, the Azure is a PAS platform. We hardly see any SAS related activities being done here. But Office 365 is off late for last 5 to 8 years. We have been seeing or listening about Office 365. Today, if you install a proper licensed Microsoft Windows on your laptop or system, you will be given Office 365 access, and majorly all your applications can be loaded in the cloud of a Microsoft Azure. Probably that you might have experienced, which was not there earlier. Maybe 5 years back, if you look at any Windows, that was not possible. But today, you have the flexibility. Once you purchase the license of a Microsoft Windows, you will be given access to your Office 365, where you can start loading or storing or saving your applications of Office related Microsoft Word, Excel, PowerPoints, and other stuff in the cloud. Not only on your system, but also on the cloud, because you will be given a username password. This is how the applications, but majorly we will be looking Microsoft Azure from a PAS perspective only, because SAS applications are not that great. Probably you can cite example of a Office 365 at maximum. In that we have various Microsoft Word, SharePoint, all those are part of the Office 365 package, and people can start using that. This is majorly what a Microsoft Azure from a PAS perspective. So with this, probably we can conclude that we have seen three practical cloud providers. One is one is AWS, which we started from a IaaS perspective from Amazon. Then we have a GAE from a Google, from a PAS perspective. Now we have seen Azure from a Microsoft from a PAS standpoint. So this is about the real-time cloud providers, what you have seen so far. So hope you could get some inputs. Any doubts in this? So if you can let me know before I go to the next topic, that is a cloud applications. Any doubts on that? Hope you could get some points.
No, sir, nothing.
Okay, fine. So probably we'll get into the last topic of our module 5, which talks about cloud applications, right? Hope the screen is visible.
Yes, sir.
Yeah. And this part, I think I have shared. Hope you might have received today, the cloud computing applications. And good amount of this application we already taken as an assignment, maybe in the form of a Google iCloud, or maybe in the form of a Facebook and other activities. And let me touch upon the though other things which we could not take as assignment, but which majorly concern about the scientific related applications. So cloud computing today, I think when you take about this particular textbook which we have been referring, maybe it is a 10-year-old. At that time, probably cloud computing applications were reserved only for certain high-level applications, maybe military applications to some extent, or maybe some scientific applications and engineering applications to some extent, and to some extent, maybe the baby steps were there in the healthcare as well. But today, we see cloud computing reaching almost all the type of domains, we can say, in the world. And it's not only the corporates or enterprises that are using, even the governments to provide services to its own public, they are going into the cloud computing. And as we have already discussed once in our class, we can look into those type of applications of government services. Maybe our Aadhaar card is one example. And today, Ayushman Bharat, what people talk about in Indian context, which is a very important step towards the health care of its own 140 crore people of India. So which is a major step and boost for the healthcare industry, or maybe the health setup of our own people. So these are the two major, there are so many, but major things what we can Otherwise, when it comes to the student requirement, all your student processing, or maybe admission process, or maybe all your scholarship related things, all your you go to the school level, there is a separate number, SSA number they are giving. Once you know the number, they can track across the Karnataka, where the student is. So it is a seamless. It is providing flexibility for a student to move from one place to another place, or to join from one school to another school. There are so many other flexibilities we could able to get through cloud computing when it is given to the mass. So thereby, so the maturity level is exponential, we can say, which was only within the IT, or maybe only to the IT domain. Now it's gone to the different domains, and not only in the private sector, it has gone to the public sector. So now people are looking at cloud. I think everybody in the world, maybe if you talk about cloud, they will say yes, there is some technology available. That is the penetration today we see with respect to the cloud computing, and it has gone to the every domain. Like we have a Uber, Ola, transport, logistics, we have everywhere this particular cloud coming into picture. That is the reason why we have mentioned here that cloud computing popularity has been phenomenal over last 5 to 8 years at least. And cloud applications, you name the field, cloud applications are there, and majorly they're helping the public to have a better living. That is the good news what we have. Many times technologies come and go, but the worry is it is going to help only a particular sector, or a particular domain, or a particular set of people. But cloud computing is helping everybody, right from a person sitting at a corner village to the people are having a luxury or across the globe. So that is the case. I think cloud computing has really made a difference in the livelihood of people, or maybe the lives. And if you see, look at the pandemic for last couple of years. I don't know if cloud computing was not there, the technology was not there to that rapid extent. I don't know how things would have happened, especially in the sector of ours, that is academics, and maybe in the technology, or maybe in the banking. If the pandemic has had hit us when in the absence of this cloud computing, I don't know. We are unable to imagine what would have been the scenario at this point in time. So if that is the case, cloud computing has really made some inroads into the all possible places of our life, and it has been there. But from the learning perspective, we are limiting ourselves to have some of the applications here from both scientific point of view, business, consumer point of view as well. There are two categories we have now. One is the scientific applications, which talk about on a high-end level. Second, we have a business and consumer applications like our Facebook and our Google Docs and other stuff, which is going to be in that category. So the main concept, or main reason rather, why cloud computing coming to the scientific applications is two. One is the HPC and other one is HTC. I think these two words we have used earlier, but I don't think we have discussed on that. Probably we can look at these two in a quick manner. HPC is one synonym probably people use with respect to the cloud computing, and later people talk about HTC, which is another synonym that goes with the cloud computing. So cloud computing, we know it is just a concept, but using that concept, people are drawing many things from its hat and umbrella and try to enhance their working, but they use the concepts in one or other way from a cloud computing. So that is the reason why cloud computing has become a buzzword in a big way in almost all the places. So coming to the scientific, you know that in scientific requirement or engineering applications, the precision is very important. And not only precision from the computation point of view, even the time, the delay, even point not second or nanosecond, picosecond, microsecond matters for them. Thereby, the speed with which the operations are done is also important. One is at the perfectionism, that is the precision at which we are going to get the data. And second concept is how quickly we are able to do the computation and analyze the situation. For example, if a rain comes, or a storm comes, or a tsunami comes, or earthquake comes, what is the aftermath effect? Why to go to that level? Look at the current pandemic itself. People are able to analyze very quickly. Sitting in December, people projected what might happen in the February month. I think that we have seen already in the previous two waves of COVID, when people could predict couple of months in advance what is going to happen. Or maybe our weather forecasting today we have a very accurate 99% of the data what the meteorological department predicts is going to happen, but that was not the case earlier. So why this is happening? This is happening because of the precision, because precision has to be very accurate. You can't miss even by 0.1%. If that is the case, things will take different levels or different shapes. If that is the case, precision is going to be very important. So your high performance computing will talk precisely about how accurately you are going to predict. Accurate means it is near 99.9999. Sometimes you should be 100. If that is the case, we call them as a high performance computations. So performance, there are so many other aspects of performance. One may be time bound, other may be the near real time data analysis or near real time inputs what we are going to get. All those things put together, we can call them as a high performance computing. So all scientific applications are going to be under this category, high performance, from a predicting or maybe from a giving a data for a future calculations perspective. That is not the end now with the cloud. Cloud is also able to give high throughput computing. So what do you mean by a throughput? Normally you might have seen this word from a network perspective. The throughput is when I give 100 rupees into the system, I'm getting at least 95, 98, 100, close to the whatever input I'm getting, then probably we'll get a proper throughput. Or in a given time frame, if I'm going to have a better output, maybe if I give 10 items for a processing, I will get 9 at least out of 10 in a given time frame, then I say I have a better throughput. So high throughput is meaning that in a given less time or a given time frame, how I'm going to get my work done. If that is the case, we call them as a high throughput related. One is a time bound related activity, other one is a accuracy or maybe precision related activity. So both are equally important in the current world. In addition to this, now we talk about the big data, we talk about machine learning, we talk about data processing. So data intensive applications are more precise now. No doubt we have data available, but whether this data is going to be helpful for me to take a call or to make a decision is what question is. No doubt people talk about COVID, people talk about predictions, what is going to happen. Are we capable enough, or the system is going to quickly scale up so that whatever we predict that is going to happen after 10 days or 15 days, are we going to ensure that or get ready for the eventuality that might be happening? We're just predicting today, it might happen, might not happen, but are you ready for that? So the data should be helping us to take a proper decision. So these are the three. So even though we started with the HPC, high performance computing, today people talk about HTC, high throughput computing from a time bound perspective, and next level people talk about intensive. The data is coming from various sectors and various sources. In every second people say some good amount of GB or TB data is getting generated across the platforms, but how we are going to judge them, how we are going to use them for our betterment is a big question. So thereby there comes your data analytics or big data, those type of names are big names that are going to come. And this data intensive, especially when it goes to the healthcare, when it goes to the flight management, when it comes to the very critical. So we call some of the systems as a critical systems. In that critical system, safety is important. If something goes wrong, suddenly a dam is full and heavy rains come. So how I'm going to evacuate those people who are around the bridge or whatever it is? So they're all very critical. So people bring the safetyness in the critical systems, and a motor vehicle fails or something happens on maybe in a flight management system. So the data what we are going to capture, how is it going to help us in ensuring that the safety of people involved is taken care. People are not bothered much about the money or the property that we lose, but people are worried much about the safety of the people involved, maybe the humans or the animals or the society at large. So these are all the various ways where cloud computing is being looked as one of the, or maybe the major game changer. So it is going to help you to accurately predict or precisely look at a particular problem, which is going to ensure us to provide the whatever the necessity or necessary arrangements in the required fields. Second, it is going to give the data not in its own time frame, but it is going to give quick relations or quick data, probably that is going to what is the time bound what we're talking about. In a quick time frame, we are going to get some much data. And not only that, the data what you capture from various sources is sensibly identified and understood and applied to the situations. These are the three critical things that make sense from a scientific perspective or a scientific or engineering applications perspective. All your healthcare will come into this particular thing, and even your as I said, that flight management, or maybe your radar, or maybe your science and technology, or your GPS. That is very important. One of the scientific application, whatever GPS we are using, that need to be taken, because that data comes from a satellite. And the satellite is not working properly, your GPS will go haywire. You may not be going to the location where you want to go. So if that is the case, they're all related here. And thanks to the cloud computing today, we're able to trace anybody on the earth. So maybe using your Google Maps or Google Earth or whatever it is. Again, the combination of a satellite images and the technology clubbed with the cloud is going to provide this particular technology or the feasibility for us too. So again, it is helping majorly the public or masses in the system. So this is how the identification today. We will be talking about scientific applications and business or the consumer applications, which are day to day we use, like Uber, Ola, and stuff like that. Let us come to the scientific applications at a major level. So as we know, scientific applications are driven by the needs to have high performance systems, high throughput systems, and data sensitive or intensive applications. And all these three can be targeted easily, or maybe fulfilled rather, from a cloud computing, because it is built to help us to have a high performance requirement to be met through precision, high throughput computing through a near requirement in a given time frame, and the data that is collected can be quickly analyzed to come to a conclusion. These are the three important things that make the life of people easier, and that's how the things are happening around us today. Even we might have seen the vaccination, how the vaccination it is a very big task, giving vaccination for the entire globe, but still it could be managed through cloud application seamlessly. So there are the various examples of cloud what we have today. And coming to the healthcare, since we are talking about a very old system of applications, we have this example of a ECG analysis in the cloud. And this book, which we are referring as a textbook for our discussion, majorly talks Aneka as a major cloud, because we know that the author of this book is the owner of a company by name Aneka, which is a PaaS platform cloud for us. And whatever the examples listed here, in the case of a scientific example here, they are majorly built from a Aneka. So from that perspective, we are learning. That is the reason why we have applications are not only, there are plenty of applications available, but we are listing only a few of them here from a understanding perspective. But cloud has given the flexibility to have applications in every field what we have today. So coming to the healthcare, so the one example what we are touching here is ECG analysis. Today, there are two, I don't know, people are talking about diabetes as one of the pandemic. We talk about COVID, but COVID is nothing in front of diabetes. So diabetes has become, I think, if you go to a house, in a random house, you see at least one fellow suffering from a diabetes or diabetes related complications. So that's how the scenario today, because of whatever the lifestyle changes we have. And this particular diabetes is giving room for the various cardiac issues as well. That's how the people talk about. When people never had any such challenges earlier, they used to live happily, but today the lifestyle change has given room for these type of silent killers, people, doctors say. So maybe the diabetes, or maybe the blood pressure, or maybe the cardiac related activities. We suddenly hear some person of a very health, we have seen all what happened to Mr. Puneet Rajkumar. Even though he is very young and happy, hale and healthy, very dynamic, we lost him for just a matter of 10 minutes. So these are all related things for a ECG, or maybe the cardiac related activities. So the main concept here is our human body is made up of so many elements, and if the proper care is not given at a given time window, because people call it as a golden hour, right? That golden hour is missed and probably will not be able to do anything. And many times the cardiac related issues go unnoticed within the body, and people assume that the cardiac related issues are for different reasons. They will not be able to understand it is an issue of a cardiac. This we see and hear every day when we talk or when we hear from this type of challenges. That is the reason why ECG has become a very important method or to understand how the health of a heart or a cardiac related system for a human being. So that is the reason why ECG, when someone goes with any complication or some congestion in the maybe the around the cardiac or maybe the heart, doctors immediately do the ECG to just understand quickly how the heart process was. How was it? How is it currently is happening? So that's the concept. So the reason why ECG analysis has been brought into the cloud is because today many people suffer or maybe lose their life because the connectivity of a network or connectivity of a healthcare data is missing. That is exactly the Ayushman Bharat is coming into picture. It is going to network all the patient related records such that irrespective of the place where you are, the doctor can access with the click of a button once you know the number of you, so that the doctor will come to know what happened for last, maybe say, suppose a 40-year fellow gets into the hospital, what happened to the last 39 years? If at all you had any health emergency or health case or any test was done, any problem if you had, all this history will come to the doctor. Because many times the problem is the patient goes to the hospital, patient is not in a position to tell what is the history behind that. When patient is unable to tell, doctor will not be in a position to give a proper treatment. So that is also reason where some good number of percentage of people are not able to get a proper health care and they lose their life. So to avoid all this, the connectivity is required, the seamless connectivity is rather required. So this is what the concept of Ayushman Bharat here. So once you register, once your data is uploaded into the system, doctors or anybody who is looking after the health of a system can access in no time, and even without you speaking as a patient, the doctor will be able to understand your complications, your history, thereby they can give some medicine. Because people are allergic to some medicine, let us say, unless you say or unless it is given to the doctor, how the doctor will be in a position to know what is allergic to you? So that is very simple example. So like that we have a this particular data. So data of a patient or data of a health record in general, keeping in the cloud is very important and paramount to ensure that the patient is survived or patient is given a proper health care. So from that perspective, ECG plays a very important role, and ECG data, if it is kept in the cloud, probably any doctor, whoever is going to treat a client or a patient in future will be able to understand what is the functioning of a heart. So if suppose a person has taken 10 ECG over 10 years, let us say, when 11th time he or she goes to the hospital, the previous 10 ECG will help the doctor in the present situation to analyze what might have gone wrong or what might have happened in the current position, how to revive or how to ensure that the patient comes back to the normal. So that the data which is going to be provided in a very less time, that is important here. Data is available, no doubt, but can I access the data in given less time? And can I access the data anywhere at any point of time? If that is the case, then we need to depend only on the cloud at present. And cloud is only able to provide that. So thereby your ECG analysis, ECG is just example. You can replace ECG with just any healthcare or any health issue. So health records are very important. That is one of the important what you call application we can say from a cloud, and you can always write or Ayushman Bharat as an example at the present time, which is completely or exactly the same what we are talking in line with the what ECG example we have given here. Our Ayushman Bharat is exactly, it is even beyond. It is only for ECG, but Ayushman Bharat for the entire patient record. They call it as a EHRs, electronic health records, which are going to be stored in a very secured form, because health records, again, okay, people should not tamper. If my health record is only personal to me, nobody else can look at it. There are some legal issues in that, because health data should not be disclosed to anyone. Only the doctor should know, not anyone else. So these are the various legal challenges are there. Considering all this, the health data has been protected. Maybe who knows, blockchain may be implemented later to ensure that the data is not tampered. So all those things will come into picture. But this is basically because of the technology that we have, which is helping us to do. So one such example is ECG is we have taken, but we can always write ECG is only one example. There are plenty of examples. Today, I don't know how many have heard about Narayana Hrudayalaya of Bangalore, Mr. Devi Shetty. And Devi Shetty is one of the technopreneur medico, I can say, because he loves engineering, he loves the technology, because he is one of the pioneer to connect the technology with respect to the he is mainly for cardiac related aspects. He quickly learned that the time that goes into the addressing or the looking at a patient of a cardiac related activities is very, very crucial. And within that time frame, if you do not act, whatever you do later is of no use. So understanding that, he has connected his network of hospitals, and today he is there in every board. It is one of the I think he's a chairman of our Medical Council of India, and he is advising people in the India. Even maybe he's again the person behind this Ayushman Bharat, because these are the people who are visionaries, who are trying to ensure, because in India doing is not a very easy task. So technology is the only way through which we should be able to find the solution. So thereby, healthcare is very important aspect, and in a country like India where public is diversified and masses are there, and today as you speak there is young generation which is constituting up to 50 to 60%. So their health is very, very important in the what you call prosperity of India, whatever we see for next 30-40 years. From that perspective, this healthcare and cloud is going to ensure. So this is one aspect what we can touch upon, and ECG, as I said, just one example from that perspective. So you can just go through this. I think this is self-explanatory. But what you have to keep in mind is healthcare is going to be the one of the biggest beneficiary from cloud computing and blockchain as days to come. And good that our governments are thinking from that perspective and they are providing. Just this diagram will talk about how the data can be just a architecture diagram in line with any. So we require IaaS, some, if not Amazon, if not S3, some cloud. Maybe you can have your own cloud, but that infrastructure is required. And your PaaS is very important, because where you are going to build your application of Ayushman Bharat, let us say. And SaaS is what, this is what actual graph. So through that application, doctor is going to understand what is your current ECG or maybe current any health related aspects. And both user also can access this, and even the doctors also or healthcare people also can access this. Once this is done, probably the next, maybe the higher system, maybe government and all can act. And for you to know as a user, you have to have this ECG sensors and other things, data will be uploaded into cloud. So this is how the cloud is going to ensure that the data is stored and retrieved as and when people are in need of this data. So this is how the concept. This is just a block diagram which is going to just summarize how this ECG can be taken, and you can generalize this for any health related activity. So that is one way. And second important thing is biology. And thanks to the technology, we have got our vaccine for COVID in a very quick time. Maybe around 6 to 8 months we could able to generate. Not only one, there are plenty of medicines have come, and they are tested and they could give it to us. So how this is possible? This is possible again, how we are going to analyze the data. Analyzing data of this, they're all critical systems. Healthcare is the critical, and biology or maybe your chemical related activities, they're all very critical. And your water, which is going to be genesis or maybe the room for various other diseases, is very critical resource for us. And how you are going to manage, and people say through the smart city management, we are going to provide a clean water, clean air. Again, smart city is based on a cloud computing concept. So cloud is going to be there in everywhere. You name the field, it is there. But we are looking at a big critical areas here now. So one, we have seen the healthcare industry. Of course, it is very critical, and cloud computing is helping us to come out of these challenges. And second is the analysis of data related to the genes in identifying the cancer diagnosis. And again, the cancer is a another lifestyle challenge what people are having in line with the diabetes and heart. So cancer is another diagnosis. Again, let me share an example what I heard from another doctor from same Narayana Hrudayalaya. So almost 8 years back, I had an opportunity to meet one of the doctors who came to BMSIT. So that man, out of the just discussion, he was telling, we lack support from engineers. That means medicos, the medical doctors, they require badly the support from engineering sector or the scientific sector or the people like you, because unless you design some what you call material for them, or unless you design some instrument for them, they are not in a position to diagnose the patient properly. If they have to go in their own way, it may take days. You take a blood, go for the sample, blood test will take 1 day. By the time patient, who knows, in 24 hours anything can happen, because things are happening every minute differently. So diagnosing with a proper set of what you call parameters is very important for a doctor, because diseases are different, and diseases are different from person to person. That is the challenge what they have. Same disease is not there, or same parameters are not there for the same disease across the group. No, if you take one disease, let us say cancer only, if you take 10 people, 10 people will have 10 different reasons why cancer has come to them. So if that is the case, they have to go to the root level, they have to go to the DNA level or a genes level. I don't know if those who have had some idea on cancer. Cancer is basically a cell related activity. If the cells get damaged, or cells start eating themselves, or cells get mutated, then probably we'll be in a position to have those type of challenges. But again, in that there are variety of cancerous cells, I can say, in the body, and people will have a different names for the cancer. But what we have to see from technology perspective is, can we identify this cancer at an early stage? And people, you might have heard people talking about stage 1, stage 2, stage 3, and stage 4, and things like that in the cancer treatment. So the narration, what I was talking about the doctor, he was telling that cancer is one of the lifestyle challenge what we face as a doctors, and even the public for that matter. But the challenge or problem in the society of Indian culture, at least, is the early diagnosis. The diagnosis is missing. And second, if someone identifies some challenge in this particular aspect, when they go to hospital, the hospital will do various what you call checkups, and finally they identify the problem. But what this doctor was mentioning is, can you have a kit at home? Because today, as like diabetes, cancer is also growing in different formats. Is it possible, when you suspect something in your body, something is wrong, can you detect, or can you check on your own, self-check, and ensure that you have either cancer or no cancer? But unfortunately, today that system is not in place. But that doctor was mentioning that this is possible in simple way if some technology or some engineer comes forward to build the solutions. So that's what he was mentioning, that there should be a close relationship among the doctors and engineers, so that the challenges what the healthcare industry is facing can be substituted or can be mitigated by the complementing the services from a engineers. So what he was suggesting is, just let us have a small torch type of a material, where suppose you feel some challenge in your skin, let us say you want to you have some doubt, okay, what type of material is it cancerous? What we can do is, we can put some light on that, which is going to be a detective test, let us say, and that light will reflect whether the cell is cancerous cell or not. That is going to be 50 to 60% accuracy. It's work. At least at home, you'll be able to analyze whether it is going to be cancerous or not. So if you have further doubt, then you can go for the checkup. But what he says is that internal or the home checkup is missing, people are unable to do, then they will just ignore that. Indian mentality is, okay, it's okay and nothing is going to happen. Then when things are aggravated, they come to the hospital. At that time, no one will be able to help them. So what the suggestion from the doctors is, can we diagnose at home instead of going to the laboratories? There are possible. You may not be able to do all, but certain tests we can do at home and ensure. So that's what the concept. So cancer is one, so that is the relation I thought let me share with you. So you as an engineer, you have all the compatibility and the competency to design those elements and help the system to grow further. So coming to the cloud here, so cloud is going to help again in diagnosing. Diagnosis requires proper analysis, and analysis is what is important here, because again the data is massive and data need to be analyzed properly and give a proper conclusion, especially when it comes to the healthcare or a critical care, what we talk in general. So cancer diagnosis again depends on the massive data that is being generated, and it has to be given for where, because you know that cancer is hereditary to in some cases, and cancer comes as a lifestyle disease in some cases, and cancer might come as a what you call as a pandemic, as epidemic, I can say. From some cases there are different cancerous elements, and cancer might come for various health issues or hormonal challenges as well. There are various reasons, but how do you identify? So the doctor's suggestion was, let us have a home kit where we can test on your own. So that's what the idea. That's a good idea, but unfortunately the technology is not there. That's what he was mentioning, but I don't know what is the status today, because the interaction was almost 8 years back now. So coming to this particular cancer diagnosis, the gene data analysis, because as we know, majorly the cancer is identified with the DNA or the genes or cells. If they get mutated for whatever the reasons, then they cause the cancer. That is the primary identification. So how to classify them? That because there are so many cancerous elements in the body, possibility, and how to analyze them and come to a proper diagnosis. What is the stage 1, stage 2, stage 3, and how we can treat them. So this requires again some good backup of data storage and analysis. Obviously cloud computing can be looked at. This is just one example of a cancer. There are plenty of such things today, lifestyle disorders, what you have. Maybe you can replace cancer by diabetes today, because that diagnosis is also very important, because there are type 1, type 2, there are various challenges associated with the diabetes, all those. So that means, so biology and healthcare are two scientific related activities what you have looked at, apart from our engineering related application. So that's how the concept here. Again, I leave it to you. You can just go through this we have just mentioned and some of the points here. So coming to the last example of your scientific related examples of cloud, we have taken one healthcare, one biology, then we can talk something about a engineering related, which is basically about your GPS, how you are going to get your satellite images processing, because we know that satellites are sending images every second, and how are you going to process them? And your GPS is completely based on this type of images, which is where you are going to get a very accurate data. So again, this talks about how quickly you can take the data from satellite, how quickly you can process them and give it to the public. This all requires again a big storage, big processing, computation, networking. That's what the precisely cloud computing is. The three pillars of a cloud is very huge computation flexibility, and very huge networking, and very huge storage. And these three things obviously required for any such technology to be prospering, and satellite image processing is one such application for a geoscience. And this geoscience is there in civil field, because they should know the prospects of the land where they are going to construct, and it is there for the Uber, Ola today, that you can connect the dots in between. So everybody is using this type of GPS related activities, and thereby people are able to seamlessly travel without any challenges. So this is how the science of maybe the engineering application of a mapping of a GPS is what we can say. So there are satellites coming into picture, and there are agencies coming into picture who are going to process, and there are applications like Google who are going to provide the final outcome to us. There are so many agencies involved in this, and that's how it is. So similarly, we have a weather forecasting. That is also an example of a cloud computing today. So there are various examples, but we limit ourselves from a understanding perspective or learning perspective to these. So healthcare, biology, and geoscience. These are the major topics in that you can write off an example of your own. That there is no restriction on that. With this, probably we can conclude the scientific applications of the cloud computing. So coming to the next type of applications, which we have talked already, the business and consumer applications. All your B2B, B2C, what you see today, they're all examples of your consumer and business applications, like CRM, ERP, your social networking of Twitter, Facebook. They're all best examples of consumer related applications, and the business applications, maybe your CRM, ERP at higher enterprise level are going to be business related applications. So this is how the concept is. I think you already taken them as a assignment. I think CRM we have already given Salesforce as assignment, and Dropbox and Facebook, and this is another example we can take, online gaming, where multiple people will be working or multiple people will be involved in playing those games, which is an example maybe among us. So these are the various applications we have from a cloud computing perspective. So I think with this probably we can conclude our module 5, which is a majorly on the real-time clouds and the applications of cloud. So let me stop here. So if you have any doubts, so let us discuss, let us know. Hope you could understand something.
Yes, sir.
Yes.
Yes, sir.
Oh, sorry, already I crossed time. Sorry. Fine, let me stop here. So anyhow, we have tomorrow's class. Tomorrow's class, I would like to discuss about the test as well as the AWS real-time, what you call, I told, right, on 8th we thought of having, but we could not do. We are planning to have. Probably will discuss with you and come back with the proper date. You can suggest me and time so that you are all available for that. We have a person coming from AWS directly. He is working in AWS. We have taken all the permissions from AWS where you will be showcasing. That is the reason why yesterday Benkaraj was asking you how many of you are having a AWS account or not. So we would like to know, and once you give the data, probably that will help us. Maybe in the next class, let me check that. So thank you. We'll meet in the next class. I will take attendance from my other faculty. Sorry, go ahead.
So can you stop the recording? I'll start my session.